So last class we learned about mole concept and some of the revision of numericals that is actually not in your reduced syllabus, but then also we need those content for doing the things that is there in your syllabus. So today we'll be doing the most important topic that is there in your syllabus, that is relative vapor density. Relative vapor density. So what is relative vapor density? It is nothing but the ratio. Relative vapor density is nothing but the ratio. It is the ratio only. It does not have any unit. It is ratio. So it is ratio of what? It is ratio of mass of volume V. Mass of volume V of the gas, of any gas, under similar conditions divided by mass of volume V of hydrogen gas under similar conditions. So what is it? Is the ratio. It is the ratio of the volume, the mass of volume of one gas by the mass of volume of hydrogen gas, provided the condition is same, provided the temperature and pressure at which the volume is measured is same. Okay, similar conditions. If any two gases have similar conditions here, any gases and hydrogen gas, if they are measured in similar conditions, then their ratio, then mass of the volume of this ratio, okay, mass of the volume of these gases, ratio of the mass of volume of these gases is relative vapor density, So relative vapor density is mass of volume V of the gas under similar conditions divided by mass of volume V of hydrogen gas under similar conditions. So what is very much important here? The very much important factor is hydrogen gas, and the gas that is to be measured, whose relative molecular mass we are going to measure, should have similar conditions, and volume also should be same. Okay, then what we can write? Relative vapor density in short. Relative vapor density is equal to relative molecular mass of a gas or vapor divided by 2. Okay, this is proved in your book, but proof is not required. So we'll directly use this. Relative vapor density is equal to relative molecular mass of a gas or vapor by 2. This you need to learn. So in short, what you can write? Relative vapor density is equal to relative molecular mass of a gas or vapor by 2. Or if you want to calculate this, then relative molecular mass of a gas or vapor is equal to 2 into relative vapor density. That means if you multiply relative vapor density by 2, then you will be getting relative molecular mass of a gas or vapor. So that is there. Definitions, the first class only I gave you, but definition you can write this way also. Relative vapor density is the ratio. This is the ratio. It does not have any unit, because the same quantity is divided by similar. This is the ratio. This is the ratio of similar quantities. So ratio of similar quantities will not have. Ratio actually doesn't have any unit. So this is a ratio. So it is the ratio of what? Of mass of volume V of the gas under similar condition divided by mass of volume V of hydrogen gas under similar conditions. And in short, we can write relative vapor density is equal to relative molecular mass of a gas or vapor divided by 2. So this way we can find, if we know vapor density, we can find relative molecular mass. If we know relative molecular mass, then we can find relative vapor density by using this formula. So this formula is important. This formula is important. This is important. In short, you can write this also. In short, you can write Vd is equal to relative molecular mass, you can write m by 2. Vd is equal to m by 2, where Vd is relative vapor density, m is relative molecular mass of gas or vapor by 2. So, this way we can use this formula for calculating either vapor density or relative molecular mass of gas or vapor. Then one note, 1 gram molecular mass. Generally in your book, this term is used, 1 gram molecular mass. This 1 gram molecular mass is also called GMM, gram molecular mass. 1 gram molecular mass is also called gram molecular mass. Same thing, they have same meaning. So why I am telling you is that whenever they ask you in question in this way, you do not get confused. For that I am telling you. So 1 gram molecular mass is same like that of gram molecular mass. If you know gram molecular mass, then that is only 1 gram molecular mass. So what is gram molecular mass? It is relative molecular mass expressed in gram. Relative molecular mass expressed in gram. For example, relative molecular mass of carbon dioxide is 44 AMU. 44 AMU. Gram molecular mass of carbon dioxide is 44 gram. That means 1 molecule of carbon dioxide weighs 44 AMU, but 6.02 into 10 to the power 23 molecules of carbon dioxide weighs 44 gram. So relative molecular mass is mass of a molecule, but gram molecular mass or 1 gram molecular mass is mass of 6 into 10 to the power 23 molecules. So that is to be learned, that you need to know. So mass of 1 mole of a substance, mass of 1 mole of a substance, what is 1 mole? 1 mole is 6 into 10 to the power 23 particles. So mass of that many particles of a substance is called molar mass. It's called molar mass. And volume of 1 mole of a gas at STP, volume of 1 mole of a gas at STP is molar volume. And molar volume of any gas at STP, molar volume of any gas at STP is 22.4 liter or 22.4 decimeter cube. Okay? So these are few things you need to know. You need to know. This 1 gram molecular mass is same with this molar mass. Even molar mass or gram molecular mass or 1 gram molecular mass means same thing. Same thing. Okay? They have the same meaning. Then mass of 1 mole of substance is molar mass. Mass of volume of 1 mole of substance is molar volume. And volume of 1 mole of substance at STP is always 22.4 liter or 22.4 decimeter cube or 22,400 milliliter or 22,400 centimeter cube, because 1 liter is equal to 1 liter is equal to 1 decimeter cube, and 1 milliliter is equal to 1 centimeter cube. Therefore, they are equal. This also you need to learn. This also you should know. Okay, now we'll be doing some numericals based on this topic. Okay? So, example number 14 of your book. A gas cylinder filled with hydrogen holds 50 gram of the gas. So, in a cylinder, there is 50 gram of the gas. A gas cylinder filled with hydrogen holds 50 gram of the gas. The same cylinder holds 200 gram of a gas X and 500 gram of gas Y. Considering the same conditions of temperature and pressure in the cylinder, calculate the relative molecular masses of gases X and Y. So the question is very much clear. There is a cylinder. The cylinder can hold 50 gram of hydrogen gas. That means when the cylinder is filled, it can hold 50 gram of gas, hydrogen gas. At the similar conditions, it can hold 200 gram of gas X. It can hold the same cylinder which can hold 50 gram of hydrogen gas when it is filled. Considering the similar conditions, gas X, gas X will have 200 gram. That means 200 gram of gas X can be filled in the same cylinder. And again, if you fill gas Y, then 500 gram of gas Y can be filled in the same cylinder. That means cylinder is same. Capacity of the cylinder is same. See, conditions are also same. But then also different type of gases will have different masses. Different type of gases will have different masses. Okay. So we have to find here the relative molecular masses of gases X and Y. Now, how can we do? So, what are the things we know here? What are the things? Here we have mass of hydrogen gas and we have mass of gas X, mass of gas Y. So, these are two different gases. Okay, so we will be doing one by one. So first of all, we know that relative vapor density, or in short you can write vapor density also. Vapor density of a gas is equal to mass of volume, mass of certain volume, or you can mass of certain volume, mass of certain volume of a gas at STP, standard temperature and pressure at STP, standard temperature and pressure, or you can consider similar temperature and pressure also. So mass of certain volume of a gas at STP divided by mass of same volume of hydrogen gas at STP. So this is the formula we know. So vapor density of a gas is equal to mass of certain volume of a gas at STP divided by mass of same volume of hydrogen gas at STP. Now, from this formula, we will be finding vapor density of gas X. We will be finding vapor density of gas X. That means for gas X. Vapor density is equal to, what is the mass of certain volume of gas at STP? That means what is the mass of Okay, what is the mass of certain volume of gas X at STP? What is given here? The same cylinder holds 200 gram of a gas X. That means it can hold 200 gram. So mass of certain volume of gas X at STP here is 200 gram, and mass of same volume of hydrogen gas at STP is how much? 50 gram. So right here 50 grams is. Now these are the same quantities. Gram cancels. That's why it does not have any unit, because it is a ratio. So 0, 0, 5 ones are 5, 5 fours are 20. That means what is the vapor density? What is the vapor density of X? Vapor density of X is 4. Now we have to find what? Relative molecular mass of gas X. So what we know? Relative molecular mass of gas X is equal to, what is the formula? Relative molecular mass of gas is equal to 2 into vapor density. So what is the formula? 2 into vapor density. So is equal to 2 into, what is the vapor density? 4. So 2 into 4 makes 8. So relative molecular mass of gas X is 8. Similarly, we will be finding, first of all, we will be finding vapor density of gas Y, then we will be finding relative molecular mass of gas Y. So let me draw this. Now, for gas Y, vapor density is equal to, what is the formula? Mass of certain volume of a gas at STP. Here, mass of gas Y at STP. Mass of certain volume of gas Y at STP. So what it is? Yeah, it is 500 gram. So you can write here 500 gram divided by mass of hydrogen is 50 gram. Gram cancel, 0 cancel, 5 1 5, 5 10, 50. 5 tens are 50. Then what do you have to find? Then we will be finding relative molecular mass. Relative molecular mass. So relative molecular mass of gas Y is equal to, this is 10, vapor density is 10, so relative molecular mass of gas Y is equal to 2 into 10, that is 20. So this is the answer. This is the answer. Now we'll be doing next example. We'll be doing next example. So what is the formula for vapor density? Vapor density, or you can write relative vapor density or simply vapor density, is equal to relative mass of certain volume of a gas under similar conditions divided by mass of the same volume of hydrogen gas under similar condition. So that gives you relative vapor density, and then relative molecular mass of the gas or vapor is twice into vapor density. So let me write question example number 15. Same page 81. What is the question? 0.583 gram of acetone when vaporized formed 225 centimeter cube of vapors at STP. Calculate the gram molecular mass of the gas. What is given? 22.4 liter of any gas at STP is equal to 1 gram molecular mass of gas. This is given. So what is the question? 0.583 gram of acetone when vaporized formed 225 centimeter cube of vapors at STP. Calculate the gram molecular mass of the gas. That means gaseous. You have to find gram molecular mass of gaseous acetone. So here you will be using this concept. 22.4 liter of any gas at STP is 1 gram molecular mass of gas. But here you are given the volume of gas in centimeter cube. So make sure that you convert this liter into centimeter cube, and then you will be getting the answer. So let's do this. So what is given here? 0.83 gram. Okay. So 225 centimeter cube of vaporized acetone. Simply you can write vaporized. Of acetone with at STP with how much? 0.583 gram. So 225 centimeter cube of acetone at STP weighs 0.583 gram. Then what do you have to find now? Therefore 22400 centimeter cube. What is this? This is equal to 22.4 liter. 22,400 centimeter cube is equal to 22.4 liter. This I have told you already is equal to 22400 centimeter cube. So 22,400 centimeter cube of acetone acetone at STP will weigh how much? Yes, this of acetone at STP weighs that much. Then 1 centimeter cube of acetone at STP weighs 0.583 by 225. Then this many means you have to multiply. So what you do is 0.583 by 225. Okay, 225 centimeter cube weighs 0.583 gram. Then 1 centimeter cube of acetone at STP weighs 0.583 by 225. Then 22,400 of acetone at STP will weigh this into 22400 gram. Okay, then you can cancel it by 5, by 4, then 5 4 20 and 5 5. This also you can do by 5. That means it will be 5 4 and 5 4 20 5 8 40. This much. 5 4 20 5 4 20 5 8 40 and 5 0. Okay. Then again by 5 5 9. Then 5 8s are 40. 5 9s are 45. Then 5 6. Then can you do by 3? No, you cannot. Then multiply this 0.583 into 8 times 6 by, that means 0.583 into 896 divided by 9 gram. Then you will be getting 58.04 gram. This will be your answer. So this concept you are using here, 22.4 liter of any gas at STP is equal to 1 gram molar mass of molecular mass of gas. So this much volume of acetone at STP weighs this much, means 1 centimeter cube. This divided by 225. Then this many, that is 22.4 liter of acetone at STP will weigh this much. That means this is what? This is gram molecular mass of the gas. This is gram molecular mass of acetone. So this is gram molecular mass. What is required here? Therefore, you can write yes. Therefore, the gram molecular mass of the gas is 58.04 gram. Calculate the vapor density and molecular mass of carbon dioxide if 200 ml of the gas at STP weighs 0.40 gram. So what you are supposed to find? You have to find vapor density and molecular mass of carbon dioxide. Vapor density of carbon dioxide and molecular mass of carbon dioxide using the formula of vapor density. And what is the thing given to you? If 200 ml of the gas at STP weighs 0.40 gram, 200 ml of the gas at STP weighs 0.40 gram. 1 liter of hydrogen at STP weighs 0.09 gram. Now what is the thing here? You can see here volume of carbon dioxide is given in milliliter, but volume of hydrogen is given in liter. Volume of carbon dioxide is given in milliliter and volume of hydrogen is given in liter. So what you need to do is you need to convert volume of carbon dioxide also in liter. Okay, volume of carbon dioxide also in liter. That means if 200 ml of the gas of carbon dioxide at STP weighs 0.40 gram means what? 1 liter of carbon dioxide, what is the mass of 1 liter of carbon dioxide gas at STP, that you need to find. Then you can compare, because that will become the same volume, because what is relative vapor density? Relative vapor density is equal to mass of certain volume of a gas under similar conditions divided by mass of same volume of hydrogen gas at the similar condition, under the similar condition. That means same volume. Volume need to be same. 1 liter of hydrogen is given, means you need to find mass of 1 liter of carbon dioxide only. You need to find mass of 1 liter of carbon dioxide. So what are the things given here? You have to convert, you have to find mass of 1 liter of carbon dioxide, and 1 liter is equal to 1000 ml. 1 liter is equal to 1000 ml. Now what we will do? We have to find mass of 1000 ml of carbon dioxide. So you will be writing here, yes, 200 ml of carbon dioxide at STP weighs how much? What is given here? 0.40 gram. 200 ml of carbon dioxide at STP weighs 0.40 gram. Mind you, your unitary means the way you solve unitary method. You should know how to solve numerical by unitary method. Then only I think you will understand this thing. Now, 200 ml of carbon dioxide at STP weighs 0.40 gram. That means if you find for 1 ml, 200 ml weighs 0.40 gram. Means 1 ml will weigh less than this, yes, or more than this. 200 ml weighs 0.40 gram. What about 1 ml? 1 ml. What about 1 ml? 1 ml. What about 1 ml? It will weigh more than 200 ml or less? Definitely, it is less. So, 1 ml of carbon dioxide at STP will weigh 0.40 gram by 200. Yes, this will be the mass of 1 ml of carbon dioxide at STP. But we need to find for 1000 ml. Then only we will have 1 liter of carbon dioxide and 1 liter of hydrogen. Then only we will have same volume of carbon dioxide and hydrogen. Then only we can find vapor density. So for finding vapor density of carbon dioxide, we need to have same volume of carbon dioxide with that of the hydrogen gas. So since hydrogen gas is in liter, so you find for liter. Otherwise, what is there? You convert this into milliliter, then you can keep carbon dioxide milliliter. So let's do then 1 ml of carbon dioxide at STP will weigh this much, that means less than 200 ml. Then if you take 1000 ml, that is 1 liter. 1000 ml, that is 1 liter of carbon dioxide at STP will weigh. Now 1 ml weighs this much, means 1000 ml will weigh more than this. So whenever it is more than, then multiply. Whenever it is less, then divide. So that is the thing in unitary method. Now 0.40 divided by 200 into 1000 gram. Into 1000 gram. So from this. Okay, now 1, 2, 1, 2, 2, 1, 2, 2, 5 are 10. So it is 5 zeros are 0, 5 fours are 20. 5 fours are 20. 5 fours are 20. Now after decimal, 2 digits are there, so you put 2 in front of 2 digit, then this, or in simple you can write now 2 gram, because after decimal 0 has no value, there is no non-zero number. So now we got mass of 1 liter of carbon dioxide. So what is mass of 1 liter of carbon dioxide at STP? It is 2 gram. Now we can find vapor density. So vapor density of carbon dioxide gas is equal to, what is the formula? Mass of 1 liter of carbon dioxide at STP divided by mass of 1 liter of hydrogen at STP. Now what is the mass of 1 liter of carbon dioxide at STP? It is 2 gram. 2 gram divided by mass of 1 liter of hydrogen gas at STP 0.09. 0.09. If you want to remove this decimal, gram you can cancel. If you want to remove this decimal, what you can do? You can put decimal after 2 also. Then it will be 0.09. So you will be getting 200 by 9. That is, now you divide 9, 200. 9 twos are 18. 20, 9 twos are 18. That means you will be getting repeating decimal. Non-terminating repeating. 22.22. You will be getting 22.22. So vapor density of carbon dioxide is then 22.22. 22.22. Now, next thing, what do you have to find? Yes? Next thing, molecular mass. What do you have to find? Molecular mass. Now, how do you find molecular mass of carbon dioxide? How do you find molecular mass of carbon dioxide then? Yes? If you know vapor density, then can you find molecular mass? Yes? Molecular mass is equal to 2 into vapor density. So, molecular mass is equal to 2 into vapor density. So 2 into, what is vapor density? 22.22 means you are getting 44.44. What are you getting? 44.44 gram you can write. 44.44 gram. So this is vapor density of carbon dioxide, and this is molecular mass of carbon dioxide. Now we'll be doing example number 17. We'll be doing example number 17. So in this question number 17, I will not be writing question. Whenever you will be seeing this video, you just go through the question, that is question number 17. Example number 17. Page 82. So what is the question here? A gas at a pressure of 700 mm of mercury and a temperature of 57 degrees Celsius occupies 700 ml. If at STP the mass of the gas is 1.5 gram, find the vapor density and the molecular mass of the gas, 1 liter of hydrogen. Homework. So this 17 is your homework. Exercise is already done in book. You just go through it. Okay, you just try to learn it. If there is any problem, you can ask me through WhatsApp or through phone. Yes, so you can ask me. Go through it. We have already done 3 numericals. So looking at those numericals, I'm sure you can do number 17. And number 18, no need. Number 18, no need. And then do some numericals from exercise also, so that you will gain more confident. Okay? So, this much for today. Thank you.